In the calculations in parts C and D, treat the javelin as a point mass. The javelin leaves the athlete's hand at a height of 1.8 metres above the ground. Calculate the maximum height above the ground reached by the javelin. So I just drew that there. There's the 1.8 metres, and it's leaving the athlete's hand, and eventually it'll hit the ground like that. Okay, and it says calculate the maximum height. So this is the height that you need to find out here. Now you already know the 1.8. If you use your equations of motion there, this is your projectile bit here. The first part, that's the projectile part there, really, that we're interested in. We're going to calculate this height and then add it onto the 1.8 metres there. We're going to add it onto this bit here, and that's its maximum height above the ground. So if we just take it as if this is a projectile starting from this position here, what do we know then? Well, we know already that vertically, we're looking for vertical heights. We have to use vertical components and so on. So vertically, what's your initial velocity? Well, if I just go back to that diagram here, this diagram here, the initial vertical velocity is this component here, and that's going to be v sine of 40. Okay, and v we know is 24.5. So our initial vertical velocity is 24.5 times the sine of 40. The final velocity at its maximum height is 0. We know that A is equal to minus 9.81, and we're looking for this height here, or this distance here. So we need S. So again, the equation we're going to use is v squared equals u squared plus 2as, and therefore S is equal to v squared minus u squared over 2a. So S is equal to 24.5, the sine of 40, minus 0, I'm not going to write in the minus 0, squared, and then it's all over 2 times 9.81. I suppose I should have said that this is minus the 9.81, but there's a minus up here too, so it becomes plus. The whole thing becomes plus. And S comes out to be a total distance of 12.6 metres. So obviously my diagram's well off scale there. But 12.6 metres, but the total height is equal to 12.6 plus 1.8. And the total height then is 14.4. Is your answer there. So there's quite a lot of working out to that. For the javelin striking the ground at the end of its flight, to calculate the vertical component of the velocity. Now, what I'm going to do is take this as if it's a projectile from here and calculate, first of all, its vertical. Sorry, that's what we do, need the vertical component. So I'm going to take it as if I now know this complete height is 14.4 metres, and I know that its initial vertical velocity is 0 at its maximum height there, and I know acceleration due to gravity. So I've got enough information to calculate v. So u is equal to 0 from the top of its maximum height there. Its initial vertical velocity is 0. We know a is equal to 9.81. We know that we know S is 14.4, and we're looking for V. And again, it's the same equation again, V squared equals U squared plus 2AS. And that's equal to 0 plus 2 by 9.81 by 14.4. And V squared, V comes out to be 16.8. Is your answer. So the last bit, calculate the magnitude of the velocity. The magnitude of the velocity is the combination of the vertical component and the horizontal component. And the vertical component is that 16.8, and the horizontal component is the 18.8. So you've got 18.8 and 16.8. and we have to get the value of the hypotenuse of that. Or I'm going to show you just, but so when you add those two vectors, then you've got 18.8, add them end to end, move the 16.6 over, and then you're finding this vector here. So it's 18.8 and 16.8. And so to do that, of course, you have to do the square root. So that velocity is the square root of the 16.8 squared plus the 18.8 squared. And that comes out to be 25.2 is your answer.